Hi everybody. Today I am going to show you modal analysis. In order to be able to create a seismic analysis, a modal analysis must be set first. And this modal analysis, it determines eigenvalues, derivative values, precisions, eigenvectors, participation coefficients, and participation masses. So, to set up a modal analysis, we will click analysis and click analysis type also. Now here some analysis types we can see: dead load 1, dead load 2, live load, snow load. This dead load 1, it is nothing but self weight. Software calculates this self weight from the dimensions of the building. But other three, say dead load 2, it is actually superimposed dead load, live load, snow load. We have to apply it on the building, and it is already applied. So let's see one as an example. Say this is live load, this one. We are here with the live loads. So let's see this one. This is the live load on all floor. Even we can see the value descriptions. Look at this value description is here. Other cases also we can find. For snow load, it is only applied at the roof. Now we are taking this out. Okay, now here modal, already it is there. I want to remove this and to do it again. Okay, so to start we have to click new modal, press OK. It will be generated on number 7. So we got it. Now there are parameters, mass matrix, active mass directions. To understand all these, let's bring this. So what it is? So let's bring on the first one. What it says, this one. This one. Number of modes. Actually, this number of modes, it depends on the type and complexity of the structures. Here it is number of modes, say 10. Say I am considering it as say 5. Just I am taking it as 5. Now here it says number of modes to be calculated. I am putting here 5. Now for mass matrix, consistent, lumped with rotations, lumped without rotations. Consistent, what it says, mass is distributed uniformly along each element. By seeing this figure, it's very clear to us what is written here. Distributed uniformly, you can see here. But for second one, lumped with rotations, mass is distributed only two nodes. We can see node here, node here. So mass is at both nodes. As well, it says with this matrix, the rotational energies of a masses are considered. This is rotational energy of masses. That is why they put here rotational sign. Directions is there for rotations. So both are same except one item, that this is without rotation. That's why there is no rotation arrow here. So we got the understanding of this mass matrix. Even this mass matrix, consistent mass matrix, it gives more accurate results. But when we use a lumped mass matrix, basically what is happening in this situation, lumped mass matrix, a portion of the structure's mass is allocated to the supports and therefore not taken into account for seismic calculation. Very important point for these two. Now let's move for active mass directions. What it says here, active mass directions. Various straight cut allow the user to specify in which direction masses are allowed to act. Very clear. And in principle, all directions, here we can see all directions are active mass directions, but sometimes it may be desired to check specific directions only. So we have to think of it. Another important points I want to mention, when the vertical mass direction is active, it will give vertical modes which can be sometimes disturbing when it is, especially when slabs are not held by columns for long distances and so they are free to oscillate vertically in that situations. Now our next point is disregard density. Disregard density, it is very important point to understand. Normally, dead load 1, in the time of conversion into mass, in case of self weight, robot software convert it automatically. So we must disregard density to modal analysis. We should not put tick. If we put tick, then it will convert double self weight. So we should be very careful on these points. So we are done now for this part. For advanced parameter, I shall discuss after this. Let's do it first. Press OK. Now we need to load to mass conversion. This is very important, load to mass conversions. Already I said dead load 1, that load to mass conversion it is done by software itself. But for other, dead load 2, which is superimposed dead load, let's take that one, dead load 2. We will check this too. So here close. So this load will be converted to mass. So when we think of converting to mass, we have to understand about the conversion directions. That is very important. Convert case is very easy. One by one we will bring like dead load 2, live load 1, and then we'll bring snow load 1. If we have any other loads also, we can bring it except the self weight. But conversion directions, normally we must select the direction of load action, which will be included as a part of the mass. But in the vast majority of cases, we will leave this set to Z minus to account for gravity structural loads, which if we wish to have contribute to the structure mass. So keep it Z minus for all. Coefficient, actually this coefficient, I mean load convert to mass, this coefficient, say here scale factor, we can put it as say 1. So add it. Now let's go for say live load. Take this case 3, bring it here, keep this conversion directions, as well coefficient here it is say 0.3. So add it. Again bring snow load, case 4, bring it here, and here also coefficient assume it as 0.3. Add it. We are done. In these positions also we have to know about the mass directions for all this. I mean for all this mass direction here, unless there are some really special circumstances, the mass will act in all directions. I mean x, y, z. So leave like that. What about add to mass? Global mass. There is other options. Dynamic mass. We are discussing only these two. Global mass, it is active for any load cases, including static ones also. But dynamic one, mass is only active for dynamic cases. So we are keeping this global mass. So we are done here. Now we can go for calculations. Let's wait for some time. So I think we are done. Just wait to get this calculation message results. Done. So we are okay now. Close it. So let's click on results. Dynamic analysis, result tables. So what is happening here? Go for advanced, then modal analysis. We'll see. Nice. See here I have taken 5 modes. And if you look at these 3, I mean this one, and this one, These three actually, it is, participation mass. So participation mass participation, how much it is? Here it is showing the value 71, 71, 73, 75. So this, it is showing this, and it is actually these two called, say, we call it as cumulative participating modal mass for each directions. This, and this is total mass. Total mass here and here, x directions, y directions. Now in this situation, say if we have interest, already you can see how many modes I have calculated, it is showing here. Maybe this situation need more modes for getting here these mass participations. It is 90%, because this mass participation should be 90%, because most of the code, they only require 90% mass participations. So how to get that 90%? We, in this situation, to get 90, we need to increase the number of modes in modal analysis parameter and run the analysis again. Suppose here mode is 5, maybe I can put 1 times 7. Another time I can, if I don't reach 90, then I can put again for 10 to see whether it is reaching 90 or not. So you have to continue the procedure until appropriate number of mode is found to get this 90% mass participations. And so what we can do, we can say we can do it automatically when we use seismic mode, because if we do seismic mode and if we put our limits, say 90%, because already I am going to explain you to put the limit in 90%, then robot will automatically increase the number of modes until it reaches that demanded participation percentage, say it is 90. So let's move for that. So what we will do, we will bring our view previous model again. So our result is here. So what I'll do now, analysis type, select model and click on parameters. So what is happening, you can see here number of modes which I have chosen, it is 5 still there, but as I said, I will click advanced parameter. Here there is the options limits. Here I will put 90, but I will go for analysis mode as seismic. So let's click on that. Right away this subspace iteration will be jumped here. So let's see that seismic, it is here. Now in this regard, I need to say something. Say here, what is that, this place, yes, it is showing here. Say I am taking this left, so it will come automatically. Okay, so this one, subspace iteration. Here it says, and this third one, block Lankos, it's very hard to pronounce, algorithm. These two are used, but it says this one, block Langos algorithm, is a much faster solutions. So we have to keep this in our mind that as we are going seismic, automatically it is selected, and it is much faster solution. What about the limits? Limits it has for so many things, but our concentration is for only this. So I will skip this. Only I will read, say, limit can be defined in order to automatically stop analysis when the certain value of the percentage of mass participation is obtained. So what is that? I will consider it is 90. As I said, most courses only require 90% mass participation. So what to do? Click here and select here 90. So we want to see that how it will increase the number of modes in modal analysis. So let's put here 90. And damping to be 5%, keep as it is. So let's click on OK. So we are done for this. Now we need to run the analysis again. So calculations. Let's wait for some time. Actually, considering this 90% mass participation, it has advantage, because it will save some calculation time when the number of modes cannot be foreseen, because we have to assume the value for the modes. Like in state 5 we can consider 7, then for 9, then for 10, then to see whether it is reaching 90% mass participation is there or not. But if we put the limit first, so it will save our time. That's what it is. So we are at the end now. So let's close this and click here now to see in advance modal analysis. Wow, you see we had 5 modes. Now it is 7 mode, because I put limits 90% mass participation. So it increases the mode from 5 to 7. And if you look at here, this one, 90% participating modal mass in direction of X and direction of Y. So we got it. And here, as usual, we are finding the total mass. I think we are done for this part of modal analysis.